So I hope you guys are aware about today we are discussing about the Docker and Kubernetes application deployment on the cluster. Okay. So before we'll start our technical discussion, so let me introduce myself and who I am, what is my background, all these things. Let me share my screen. Myself, Murali Mohan. I'm working with Genesis Tech Solutions Private Limited currently as a DevOps trainer. So I have overall 8+ years of experience into IT. I'm the fast. So 4+ years of experience into the IT trainings. Also, I handle the corporate trainings as well, online trainings as well. So this is my overall experience with teaching field. So currently also I'm working with the different institutions to train the students in US, UK, and from India students. So this is all about myself. Also, we can see that these are the clients which I delivered recently for the corporate trainings. Also, I currently also have 3 batches, including certifications and AWS DevOps batches. Okay, it is all about myself. Now, in today's sessions, we'll discuss about what is meant by Docker, what is Kubernetes, and how you are trying to deploy the application in the Kubernetes platform. Before you understand about what is meant by Docker and Kubernetes, so we have to understand about what are the different kinds of applications we have and how we are trying to deploy the application to the Kubernetes platform. Okay, yeah. So before I will jump into technical discussions, I just want to put in front of you guys there are 2 questions. The first question: can I get response for the what is meant by application? The question is what is meant by application? I see the response in the chat. Yes. What is meant by software application? That's my question. Yes, you're correct. It is software to do task. Okay. And a tool to automate tasks. Oh, great. Okay. I'm just waiting for the response from you all because you guys all aware about what is meant by software application. So could you please anyone can respond to the question? I see some responses. That's great. Okay. So let me explain what do you mean by application first of all. So there are different types of applications we have. We have desktop applications and also we have the web applications. Also we have the mobile applications. So these are the different kind of applications available right now. You have to understand first what do you mean by application. Okay. See, application is a software. Application is a software and it help us to perform a task. Help us to perform a task. In this here, these are the different types of applications we have. See, for example, if you want to do the online shopping, usually what you will do, we'll just go to the web browser and you just open the new tab and you just hit the flipkart.com, right? When I just hit the flipkart.com, I'm able to get Flipkart application. Now, behind this Flipkart application, there is a software development team. They write all the source code. We can see this. This is a source code which is available, which is written by the software development team. And if you just go to this again, if you just type the command called amazon.in, now hit the enter, we can see that we'll get Amazon applications. So each and every application we develop with a software development team. Now, when the software development team try to develop the applications here, so basically we have 2 kind of application model we have. One is a monolithic applications. Also, we have to understand about what do you mean by microservice applications. So I'll tell you what is the connection between monolithic application, microservice applications, this particular Docker and Kubernetes. Okay. First, try to understand about what do you mean by monolithic application and what do you mean by microservice applications. So anyone have any idea about what do you mean by monolithic application? Can I get response? What is meant by monolithic application? If you know, if you just may yes, or if you don't know also, that's fine. I'm going to explain what you mean by monolithic application. Yes, please. Yes, go ahead.
Hello everyone. Monolithic application is where all the application is they are running. Everything is built in one. It runs off everything. It runs on a particular server. You have the application. Everything is so basic. What I'm saying is the application when it's written to run on just on a particular server. So if it crashes, anything happens, everything grinds to a halt. But microservice is where everything that provides, like the Flipkart or Amazon, there are different sub applications all linked together from different servers to work together to provide that service. That's what I know.
Yeah, great response. Thank you very much. Yeah. So I have some response in the chart. It is developed through the AS. It is developed through AS1. Integrate applications is a monolithic application. It's like a single tier application and microservice is the okay, fine. So finally, I got some responses in the chart as well. So Pat is explained what you mean by monolithic application. That's great. Now let's try to understand about first what you mean by monolithic applications. So very simple that we need to understand about what is meant by monolithic application. So before we talk about what is meant by Docker and Kubernetes, we have to understand about the monolithic application. See, for example, I will take the Flipkart application. The Flipkart application, we have different kind of services available, right? So if you just observe this Flipkart application or Amazon application, whatever it may be, whatever you can be able to see, this is what we can call as a user interface, right? Just go to here, and it is nothing but user interface module. And if you just look at the website, if you can see there is a option called as a cart module. So where we can able to select all the product which you require, we can able to keep in a cart, and whenever there is offers, we can able to go ahead and we can able to place an order. Just go to here, mention what is a cart. Okay, once cart is done, then we go for here. So we have the login module. That means user can able to create account and they can able to sign in with the username and password. And also we have the something called as admin module. Also we have the vendor admin module. What do you mean by vendor admin module? If we just look at the Flipkart application, so we will just go to the mobile phones. The mobile phones have the different vendors, right? We have a Samsung, we have Redmi, and we have Apple. So they are going to sell all the products in the online platform. Definitely they require a login form where they can able to log in, they can able to upload in the background all the products, all the details they want to add. Also we have something called as a orders module. So where we can able to place orders with this particular orders module. So these are the different kind of modules available in the Flipkart application. Also we have something called as a database server. Also we have. What do you mean database server? See, when you just click on the login button or when you click on the sign up, if you just click on the sign up, here we have to add your mobile number. Also we just need to add your first name, last name, email address. So where it is going to save all the data, it is going to save all the data inside my database server. What I am trying to explain is nothing but that all the modules will link together and we are trying to deploy as a single module. Somebody is disturbing session. Please don't do this. Okay. Yeah. So we'll combine all the modules in a single unit, and we are trying to build the project. Once we build, we'll get it. There is a WAR file, or now once we got the WAR file, we're trying to deploy this particular WAR file into where? Into the server. Okay. So now all the modules links together and there is a dependency and we are trying to deploy where? Into the server. Okay. So this is what we can call as a monolithic application. So now we'll talk about what do you mean by microservice applications. Now, what do you mean by microservice applications? So we are going to break the application into the number of services. We can see that if we just look at this, the document. So we are going to break the application into separate operations. What do you mean by separate operations here? So we have to make the application independently, scalable, stateless, highly designed, available. Before you talking about microservice applications, so we have to understand about what are the advantages, what are the advantages and disadvantages. Disadvantages we have to understand. See, what do you mean by advantages? Advantages compared to advantages. So we have more disadvantages. So we'll talk about what are the disadvantages we have. Now, when you just combine all the modules together and you try to deploy to the server, what happening here? There is a dependency is increasing. This is what we can call as a tightly coupled application. Now, also for example, I have a deployed to the server, but I'm getting more traffic towards my server. See, for example, Flipkart is announcing there is a big billion day. So normally I'm trying to get, there is a 1 million request towards my server. But when I'm just going to announce the big billion days offers, that means for the products I'm just giving a huge discount. So for example, Apple iPhone, you will get it for normally you will get it for $500, but in offer price I'm just giving for $250. So that how much discount you are getting? You are getting $250 discount you are getting. When you're getting $250 discount, that means all the customers will try to purchase iPhones to the Flipkart website. So what's happening here? There is the traffic is increasing. So we need more number of servers to handle the traffic. So if you're not getting much traffic, you have the servers, that's fine. But when you're getting more number of traffic towards application, if you don't have to handle this particular application capacity, so automatically application going to be crashed. That is the reason only. So we have to scale your application. When you want to scale your application, what you want to do is nothing but, so we have to add the more number of servers. See, to which service I'm just getting more number of requests. I'm getting more number of requests to orders module, right? So now it is very difficult to scale up a particular service which I'm getting more number of requests. So now if you just look at the disadvantages, the minor code changes, we required to full recompile and we have to retest the application. See, for example, if I done small changes, the code in orders module or login module. So again, what you want to do, we have to recode, we have to recompile and we have to retest it. And also application becomes single point failure. What do you mean by application single point failure? If I'm just getting more number of traffic towards my orders module, if orders module is not able to take up the traffic, automatically it is going to be crashed. When it's going to be crashed, all orders modules also going to be shut down. So this is what we can call as a single point of the failure application. And what is the one more disadvantage we have? Application is difficult to scale up. So these are the issues which we have if we'll go with the monolithic application. So because of these disadvantages, we'll go with something called as a microservice application. What do you mean by microservice application? Microservice is nothing but so we are trying to converting the application into independent services. That means I'll just make it user interface is one module, and also the cart mod is one module, login is one module, and admin is one module, and the vendors admin is one module. So I'm just going to break the application into independent services. Orders is one module. Also we have the database is one module. So each and every service I'm just going to run independently. So break the application into separate operations. Break the application to separate operations. Make the application independently scalable and stateless, highly available by the design. So this is what is called as a microservices. That means each and every service will run independently. So when you want to deploy each and every service independently, we require a servers. Now, if you go with the each and every service you want to deploy into the server, obviously the cost is going to increase, right? See, for the user interface, we required one server. For cart, we required one server. And for this login model, we required one server. Also, if you just go to admin model, we required one server. We can see that. So each and every service we have to deploy into the one particular server. Okay. So now, if you want to go for this particular independent servers, what we'll be having here? The cost is increasing. The cost is increasing. When the cost is increasing, that means, so obviously we have to invest more on infrastructure. But what is the business principle? So we have to invest lesser amount and we have to get maximum profits. If we'll go to IT industry, if we'll go to manufacturing industry, if we'll go to any of the industry, the principle, the fundamental rule which we need to follow is we have to invest less amount and we have to get less amount and we have to get more profits. Okay, this is what we can call it as the business, the fundamental rule. Now, how can we achieve this technique? Now, with this, we have to go with this tool called as a Docker. So, a Docker is a tool. It is help us to create containers. So, containers is nothing but a virtual machines. Now, we can able to create a containers with a Docker. So, Docker is a tool. It is help us to create a containers. So, each and every container we are trying to deploy inside the Docker image. The first, confirm. Are you guys understand about what do you mean by monolithic application and microservice? Is it clear to everyone? Can I get response in the chat box? I can see that there is some questions in the chat. Docker is used to manage the services. You will get it. You will get to know after some time. And is monolithic application is developed under one server, right? See, monolithic application is nothing but we combined all the modules, we combined all the services which are database server into single tile, and we are trying to deploy to a server. That is what we can call as a monolithic application. Okay. Now, just try to understand about now why Docker came into the market. Okay. So now, when you want to deploy the application into the servers, we need to invest the more. We have to invest more amount in infrastructure. But when Docker came into the market, basically, it is help us to create a containers. It helps us to create a containers. Now that is what we can call as a containerizations. If you want to understand the containerizations, you have to understand about first what is meant by virtualization. So what do you mean by virtualization? You have the big server. Let's say, for example, it is a 250 GB of RAM. Let's say you have the 100 TB storage. We have 250 GB of RAM and we have 100 TB of storage. Now I'll just break this high configuration computer into small computers. This technique, what we can call as a virtualization. We will just go to here, try to understand about what do you mean by visualizations. Okay. Now we can see that we have a hardware. On top of that, we have a base operating system. On top of that, what we have? So we have to install a software called as a hypervisor or Oracle VirtualBox. On top of that, with help of the software, we can able to create virtual machines. Now, this process, what we can call as a visualizations. So this is my hardware. Inside the hardware, we have 250 GB of RAM and we have 100 TB storage. Now on top of that, we have the base operating system. On top of that, we have the hypervisor. Okay. On top of that, we have a virtual machine 1 and we have the virtual machine 2 and we have a virtual machine 3 here. So these are the 3 virtual machines we have created. Now when you create the virtual machines, so we have to pre-allocate. So we have to pre-allocate RAM and also we have to pre-allocate storage. And Once you pre-allocate RAM and storage, and we have to install the guest operating system. So because every application we have to deploy a different environment, so we have to install the guest operating system. On top of that, we can able to deploy the applications. Okay, we can able to deploy the applications. Now, this is what we can call as a virtualization. Now, where is happening the virtualization? Virtualization happening on the hardware level, because on the same hardware we are trying to creating we're trying to creating n number of virtual machines. Let's say, for example, here the virtualization performing on the hardware level. So we have the hardware level, we are performing the virtualization. Now, when you want to create a virtual machine, so depends on your requirements. Assume that we have Flipkart application, and the Flipkart application we have user interface, we have orders module, and we have, let's say, for example, other module. Let's say we have orders module, cart module, and we have admin module and login module. So each and every module we try to deploy into the particular server. Now, when you want to create the virtual machines, we need more resources. So because of this reason only, we'll go for the Docker. Just try to understand in the virtualization technique what is the advantages, what are the disadvantages. The multiple OS in the same machine, easy to maintenance and recovery, and lower your total cost of the ownership. These are the advantages. If you just understand about what are the disadvantages, if you create multiple virtual machines on the same hardware, it will lead to the unstable performance. For example, in your mobile phone, if you install more applications beyond your RAM capacity, what's happening here? Your mobile phone is going to stuck. When you click on the open the app, it will take some time to open the app. That is what you have to understand. That means if you create multiple virtual machines on the same hardware level, it leads to the unstable performance. Hypervisors are not efficient as a host operating system. Hypervisors are not efficient as a host operating system, and it will take long boot up process. So it will take long boot up process, will take approximately 1 minute. These are the disadvantages what we have. Okay. Now it will just come down. We have to understand about what is the advantages if we will go with this particular hypervisor. Now you have to understand we can able to have the better resource pooling, and one physical machine can divide into multiple virtual machines, easy to scale, and virtual machine in the cloud can rapidly elastic, and we can able to go with the pay as you go base model. It is nothing but on the cloud platform. Now, why Docker came into the market? Why we have to go with the Docker again? See, when you have the microservice applications, as we discussed that each and every microservice application I want to deploy into a different server, right? When you go for the virtual machines, these are the disadvantages we have, right? Now, because of this reason only, we'll go with this particular Docker. Each virtual machines required CPU allocation, storage, RAM, and guest OS. And the more virtual machines you run, the more resources you need. See, for example, you have 100 microservices you have. So we have to create 100 virtual machines to deploy each and every microservice on the different virtual machines. Now, this is the reason only. So we have to go with this particular Docker. Application portability not guaranteed. What do you mean by application portability? The application which is tested on my dev environment, I will test the same application in the production environment as well. Before you go to production environment, we have to test the application in the dev, test, and EOT environments. So when you want to test the application, we have to carry the source code, we have to carry the dependencies, we have to carry the libraries, and also we have to configure the server. So each and every way, if we want to test the application, it is application portability is not guaranteed. That is the reason only there is a technique came into the market called as a containerization. What is the containerization? We can able to create n number of containers with help of the Docker. Okay. See why we go for the containers actually. We go for the containers because of this reason. What is the reason we go for the containers? It is going to standardize the package for the software and dependency. Now, if you just observe the container, normally I'm talking about. If you go to any shipping ads, or if you just normally look at the containers, it is carrying some goods from one place to other place, right? Before it is carrying the goods, so the manager is going to just dump all the products, whatever they want to carry from one place to other place. They're just trying to log the container, and if it just until it is going to destination, no one can able to open the door because they doesn't have the right to open the door, and they can able to get something what they inside the container. In the same example, I'm going to applicable here. Container is nothing but it is going to carry the software application, the source code, dependency, library files, the configure files from one mission to one particular environment to other particular environment in the software industry. So because of this reason only, development will happen faster, testing will happen faster, and we can able to deploy the application as soon as possible in the production environment. So because of this reason only, we'll go for this particular Docker. See, this isolate apps from each other, and we can able to share the same OS kernel. And now let me explain this point. Now how to create a containers right now? So we have a hardware. On top of that, we have a base operating system. On top of that, we have to install a Docker. On top of that, we are going to create a containers. When you create a containers, we don't require to pre-allocate RAM, storage, and also we don't require to install a OS. Okay. Now, all the operating systems, application servers, it is available in the form of Docker images. Now, if you require the Docker images, we have to go with the public registry that is called hub.docker.com. See, for example, if you want to create a Ubuntu container, if you want to create a Amazon Linux container, if you want to create Red Hat container, we have to go to explore, and if we just go to the search button, I'm trying to search for the Ubuntu container, Ubuntu image. Just hit the enter. We can see that Ubuntu image is available. All the operating systems available in the form of Docker images. All the Docker images available in less MB size, and we can able to create a container within a fraction of seconds. And if you go with the Docker, we can able to replicate the same environment as within fraction of seconds. Now, this is the advantage if we'll go with the Docker. So let me show you how to install Docker on the Windows platform. Also, I'll explain about how to install the Docker on the platform called as a cloud also. So we'll focus on the how to install Docker on the Windows platform right now. Now, how to install Docker? We have to go with the docs.docker.com. It is the official website. Now, if you just go to the download and install, we can see that which operating system you are using. Whether you're using Mac OS, if you are using Windows, if you are using Linux operating system. Now, for example, if you go with the Windows, we can see that how to install Docker Desktop on the Windows platform. Now, welcome to Docker Desktop Windows. This page contains the information about how to install the Docker Desktop. Now, before you install Docker Desktop, we have to understand what is the system requirements. It is very important that they will check the basic information whether you have worked on the platform or not. I personally place the question in the interview. What is the RAM requirement if you want to install Docker on the Windows platform? Now, how much RAM we require? If we install Docker, it is installed for Docker. We required 4 GB RAM we required. And also we required Windows 11, 64-bit, or we have to go with Windows 10 64-bit firmware Pro Edition. And we have to enable the WSL feature on the Windows page. Now, if we enable this WSL, then only we can able to install Docker on your Windows platform. And also it must be required 64-bit processor and 4 GB RAM we required. In the BIOS level, the hardware installations should support in the BIOS settings. Now, how do you just check? If you just mention Control or Delete, go to Task Manager. If you go to Task Manager, if you go to Performance, so we can check that whether visualization is enabled on the BIOS level or not. So if you go to visualization, we can see that it's got enabled on the BIOS level. We can see how much CPU it is utilizing, what is the memory, how much disk is taking. But apart from that, we can see that visualization got enabled. If it is enabled the visualization, then only we can able to install Docker on the Windows platform. So there is a question in the chat box. Somebody having still required to get understand about why we go for the Docker. See, Docker is an open platform for developing, shipping, running the applications. If we just look at this image, we have a software developer. They're writing the source code. So we'll take the source code from the GitHub repository and we're going to write Docker file for this. And we're trying to convert this source code into my Docker image. In the Docker file, we're going to include instructions, how we have to build Docker image. In the Docker instructions, we're going to write how we can deploy the application into the container. Now, once we convert into Docker image, this Docker image we are trying to deploy into where? Into the container. For example, if you want to test the application in the dev environment or staging environment, so we are trying to push this Docker image into hub.docker.com and we are trying to get this Docker image wherever you want, and we are trying to deploy into the container, and we can check that with application working properly or not. We don't require to carry the source code. We don't require to configure your server. We don't require to set the environment if you want to test the application. So this is what we can call as a Docker enables you to separate your application from infrastructure, so we can deliver software very quickly. Now, how do you deploy the application very quickly? We have to understand. For example, if I'm writing a Java code, if somebody wants to run the Java code on their laptop, we must install Java software. If I'm writing a Python code, if you want to test the Python code, you must install Python. The same way, if you want to run the Java application, we have to must install Java. But if you convert this particular Docker source code into Docker file, run the Docker file into Docker image, we don't need to bother about the infrastructure. We can run Docker image on the Windows platform. We can run Docker image on the Linux platform. We can run Docker image on the Mac OS, wherever you want to run. Okay. So Docker is tool to perform operating system virtualization, also known as a containerization. That means when you create any of your containerization, so it doesn't require to install the OS kernel, because so we are trying to pull this particular Docker images. The Docker images doesn't contain the kernel, so we are sharing the kernel, same kernel to all the Docker images. Okay. Now, so this is all about Docker. Now let me show you practically how do you build a Docker images. Now first, we have to install the Docker on the Windows platform. If we just go to this particular home, if we go to the download install, now if you just click on the Docker desktop, just click on the Docker desktop for the Windows. It is going to download this particular .exe file. I have already .exe file. Let me go to the Windows, go to downloads. We can see that there is an option called as a Docker. If you just go to Docker, now I already downloaded this .exe file. If you just click on double click on this particular .exe file, it is trying to install Docker on my Windows platform. We can see that it is trying to install it. Now click on yes. It is trying to install Docker on my Windows platform. We can see that. Look at my screen. Docker desktop initializing. It is trying to install Docker desktop on my Windows platform. It will take just a few seconds. Let's wait for the installation of my Docker. We can see that. Now click on OK. We can see that it is trying to install Docker desktop on my platform. Just trying to unpacking all the files. It is trying to install Docker on my Windows platform. Yeah. If you want to become a DevOps engineer, frankly speaking, we don't require any programming language. So, but we have to understand about how to write scriptings. So, in going forward, I'm going to say we're going to start a DevOps course from tomorrow onwards. So, meanwhile, let me explain we're going to start DevOps master program from tomorrow onwards. In this master program, we're going to explain about DevOps tools and Linux. Also, we're going to cover AWS services. So my student, they don't want to go for the proxy. They don't want to take support from anyone. So because of this reason only, we have designed the curriculum such a way that the duration of the course is a 2.5 months. Okay. And also in the DevOps tools. So I'm going to explain Git and GitHub. Also, I'm just trying to explain about Docker and Kubernetes and Ansible. I'm going to explain about Ansible. We'll talk about SonarQube and Terraform and Jenkins, Nexus, and we'll discuss about Grafana and Prometheus, and we'll discuss about Maven, and we'll discuss about application servers like JBoss and Apache Tomcat. This total course, it will take 2.5 months. Okay. In AWS, we're going to cover the services like EC2 and IAM, VPC, and Route 53. Also, we'll explain about RDS, okay, and elastic load balancers and auto scaling. And also, I'm going to explain about ES3. Okay. So apart from this, we're going to cover AWS CLI. Okay. So these are the services which I'm going to cover in this particular, the course curriculum. Okay. So this is what a DevOps Master Program. Tomorrow we have a demo session at 8:30 p.m. IST to 9:30 p.m. IST. This is our demo session timing tomorrow. If anyone would like to learn this DevOps end-to-end, practical oriented, the way I am teaching right now, I'm going to start from the basics to advanced level, because I deliver so far advanced level. I deliver so far 42 batches, including corporate trainings I'm talking about. Okay. Including corporate trainings. I have 2 more corporate trainings still in my pipeline. Also, daily I have 4 batches right now, including certifications. Now, this if what is the advantages if you enroll with us? If you enroll with Kalyan IT, what the advantages you will get it? We're gonna teach Docker and Kubernetes certification level, because I'm a certified trainer. So we're gonna teach you this Docker and Kubernetes certification. If you want to go for certification, you don't require to invest amount again to like 12,000, 40,000 to train on the certification syllabus. So here I'll explain how to take the certification, what the syllabus is coming up, and how to take the certification exam. Today also, if you believe or not, I'm just forwarding to my students. There's a 50% offer going on in the certifications. So if anyone required, I'm going to share the coupon code in the WhatsApp chat, in the group chat, I mean, say Zoom chat. You can able to get a coupon code as well, because I have already handled 7 batches. In the 7 batches, I think 42 students cleared the CK exam certification. If you can see that, this is a certification coupon code. If you would like to go with this certification, I'm here to help you out now how to get how to clear the certification as well. Okay, this is all about the course, the curriculum. If you guys have any questions, any queries regarding this course, try to contact the admin team, the Kalyan IT. So they will explain about, they will share the syllabus copy with you guys. Also, they will explain about the fee structure, everything about the course. Okay. Now, yes, that's what. If we want, I will explain everything about a real-time projects. If we'll go with the Docker and Kubernetes, I have dedicated open source certification, open source project I have. It is from the Google, and I'm just clearly explained in this particular real-time scenarios, how to work as a DevOps engineer in the real time. For this, let's say, for example, I'll show you one project. Okay, let's go to here. If you'll just go to the microservice application, which is going to provide by the Google Cloud, and in this particular application, there are 10 microservices is contained by this particular Google application. We can see that this is application, and these are the microservices which we are trying to explain. And I'm going to show you how to work with this particular project as well. This project also you can able to include on your profile when you go for the interview. Along with this project, I have two more projects I have. So totally we'll explain about 3 real-time projects. Also every day we're going to explain about, we're going to provide a real-time task, real-time projects. Also every day we're going to explain about real-time tasks, and every weekend we're going to assign some assignments for the students, because if you complete the assignments, then only you will get it hands-on experience. Okay, that is the whole total course curriculum. Okay, the timing will be 8:30 p.m. IST to 9:30 p.m. IST every day. The course fee you have to check with my admin team. Okay, you can able to, my admin team will contact you, and if you need more information about, they will help you out. And if you want to become a DevOps engineer, we don't take about any coding language. Believe me, we need only scripting languages. We are learning about AML scripting. Also, we'll learn about Groovy scripting. Also, we'll learn about declarative scripting. Also, I'm going to explain about shell scripting as well. So these are the scriptings which I'm just going to explain in this particular curriculum. So it is helpful a lot to how to we can able to do the automation. If you go to Docker, if you go to the Kubernetes, if you go to Ansible, if you go to the Docker, everywhere we are using AML to automate the tasks. Okay. Now I think that it is all about the course curriculum. So course details like how many months duration, what is the timings, and also I just see this how many projects we can cover. The complete details we will provide. If you just look at my screen, it is got installed successfully. Now click on close. When you click on close, I can see that there is a Docker. It is desktop is available on my local machine. If you just open your Docker desktop, we can able to see there is a UI interface. But Docker is a command line tool. Also the Kubernetes is also the command line tool. Okay. Now, yes, the course include Linux as well. Yes, Pat. Now just click on accept. If you click on accept, I can see that it is loading Docker desktop on my Windows platform. Now, whatever I'm just going to perform in the command line interface, I can able to see the UI interface. What is your role? Let's say, for example, if initially you are trying to learn this particular DevOps, let's go with the DevOps specialist. What will be used for the DevOps password? We can say local development. Now click on continue here. Starting Docker engine. It will just take the few seconds to appear Docker engine. Let's look. Whatever I'm just going to explain the 15 minutes. The remaining 15 minutes are very, very important. Okay. We can see that starting a Docker engine. Docker engine is the underlying technology that runs the containers. We'll just wait for a few seconds. It is time to create a containers. Yes. Now skip this tutorial. Now you can see that. Have you seen any containers as of now? No. Have you seen any Docker images? No. If you want to see any volumes? No. If you just go to environment? No. I don't have any environment. If you want to work with the Docker and the Windows platform, we can use the CMD, or else we can able to use PowerShell as well. So let me go with the PowerShell, the Windows PowerShell. It is a command line. Okay. Now we'll just type the command called docker -- version. We can see that what version we installed as of now. We installed Docker 23.0.5. And if we just type the command called docker info, I can see that what information, or we can see all the information about Docker. Let's see how many containers are there, how many Docker images will be there, how many containers are running, per stopped, how many images are version, everything I can able to see over here. Okay, that's fine. Now, once we just got this one, then what you want to do? I want to show you how to build a Docker image with a source code. See, I have the source code, everything is available at my GitHub repository. Let's go to here. Yeah. Now, both are the command line interfaces. Okay, you can use any of this one. That's fine. Now, for example, if you'll just go to here and type my Python application, I'll just say take Python application right now. Go with the Python. Now hit the enter. I'm searching for the application which is called as a Python application. Okay. Let me go to the my repositories. Okay. Just click on the checkbox. Now remove this one and search for Python. If we'll just go with the Python, 1 second. Let try with the Flask. Okay. Just go with this Flask Docker application. Now I have all the source code, Docker file, everything is available in my github.com. So what I will do, I'm just going to clone this repository into my Docker host environment. How to do it? First of all, just go to Windows PowerShell and type the command called git clone. After that, we have to clone the source code. Go to code, copy the URL, and if you just go to here and mention Control B, now hit the enter. We can see the destination path. It is already existed. It is not an empty directory. So let me go to cd dot dot. I'll go with the cd dot dot. Now just type the command called dir command. It show you all directories. Now, for example, I will just go to a Flipkart application. Let's go to the Flipkart. Okay. Now just type the command called git clone and just Control B. Now hit the enter. I'm just trying to download the entire source code, Docker file into where? Into my local machine. Okay. Now if we'll just type the ls command, we have a folder called as a flask-docker-. Now go to inside this particular directory. The directory what we have called as a flask docker app. Now hit the enter. Now where you're currently, I'm currently inside the flask-docker application. Now hit the enter. You can see there is a app.py file, Docker file. So whatever the required for a project, all the requirements, Docker file, everything is available in my github.com right now. Now just try to understand how to build Docker image. Very simple. Just type, when you want to build a Docker image, as per this image, what we require a Docker file. Right now we have the Docker file. Docker file is a text file. It contains all the instructions how to build Docker image. Okay. Now just type the command called docker build -t. Now I just want to provide a image. So for example, I'm going to provide a demo-python is my image name. When you provide the image name, all the letters should be small letters. Now we have to mention the path of your Docker file. If it's located a different file, different location, you have to mention -f. After that, we have to provide the location. Now, where is my Docker file available right now? It is available right now in my current directory. So mention dot. So docker build -t stands for tag the image. I'm just going to download into I'm just going to build Docker image with my Docker file, which is available. We can see that it is going to just build Docker image as per the Docker file. Load the building definition from the Docker file. And we can see that it's trying to execute each and every instruction what we have written inside the Docker file. Now it is trying to build Docker image with instructions what you have written inside the Docker file. Now just wait a second. It is trying to build my Docker image. I will explain about how we can able deploy this Docker image into the container. Okay. It is still building my image. Just wait a minute. When it start the building the Docker image, what this command is it for? The which command you are asking about, Bharat? So when you want to build Docker image, so we have to use a command called docker, the build -t. So we have to provide image name. After that, we have to provide Docker file location. Okay. So this is what we have to provide the command. Just look at my screen. If we just type the command called Docker images, I can see that the Docker image, the name called demo-python, latest image ID, created 13 seconds ago. And if we read the real definition of a Docker image, we can see that we have the Docker image right now available. Now, I want to deploy this application into the container. Now, how to deploy this application to the container? What is the command we have to use? Now, so we have to use the command called as a Docker. Let me just go to here, PowerShell. Now just type the command called Docker run, and after this, we have to use the command called -d -p. -d stands for a daemon containers. Okay. Now I'm just going to create a daemonized containers or a detached mode, which is running in the always in the background. Whenever I'm going to send the request, I'm getting the response, right? Just type the command called Docker run -d -p is a we use to assign the port numbers. For example, you have to assign the port numbers which are required. Okay. Now we have to mention the Docker image name. What is my Docker image name? Demo-python. In this particular port numbers, it is nothing but my host port number. It is nothing but my container port number. So on this port number, my application is running. And this is a port number which you are using to access the application to the web browsers. Okay. This port number we can change, but this port number we cannot able to change. Now hit the enter. We can see that container got created. Now if you just type the command called docker ps, I can see that the image which I deployed into the container, right? What is the image name? Demo-python. The command python3-m flask created 5 seconds ago. The status up 3 seconds ago. Now if you'll just type the command called docker port and provide the container ID. Copy the container ID, mention control V. Sorry, let me copy the ID. If you want to see the port numbers which you assigned, just mention control C. Now just control V. Now hit the enter. We can see that I assigned the port number 5000. Also I assigned the port number is a 5000. Okay. Now how to access this application to the web browser? If you just go to the Docker desktop, if you go to container, I can see that what container I created. It is nothing but container name. If you don't assign the name, it will take the canonical names. We can see which image I deployed, what is the status of your container, which port numbers we used, where it is got created. If you want to stop the container, we can able to stop. If we'll go to actions, if you want to open in the terminal, you can open it. And if you want to copy the Docker run, also we can able to see this. Now just click on the port numbers. Now I can see that I'm able to access the application which I deployed inside the container. So this is the application which I deployed inside the container. I'm getting response from my container. We can see hello from Flask and Docker. If you want to test this one, if you go to the new browser, now mention Control V, now hit the enter. I can see that my application running successfully. So this is how we are trying to deploy the application. Now, I hope so far you guys understood. Anyone have any questions? Very simple. We have all the source code available at my github.com. We're trying to clone the repository. After that, we have to enter the command called as a docker build command. You're trying to build Docker image. After that, you're trying to type the command called docker run -d -p. You're trying to deploy the application to container. Now the application running inside the container, I'm able to access the application. We can see that I'm able to access the application to the web browser. Now this is how we have to install, how we have to deploy the application to the container, right? Now why we have to go with the Docker? Then you have the application and you deploy to the container. Now just try to understand. I will take another 10 minutes. Just try to understand why we have to go with the Kubernetes. If you want to go with the Kubernetes, there is a solution for us. You have to understand why we go with the Kubernetes. The first point, containers are not self-sufficient. containers are not self-sufficient. What do you mean by containers are not self-sufficient? See, when you deploy the application inside the container, if anything happened to the container, if container crashed, if container crashed or the container dies, what's happening? The application which is running inside the container, I'm going to get application downtime. See, if anything happened at midnight, who can take the responsibility? Now again, I should wake up. I should log into my server. I want to check what's happening inside the container. Why it has got down my application. I have to check each and every point. So, but it is not a best recommended approach. Because of this reason only, we'll just go with this something called as a Kubernetes. Kubernetes is a container orchestration tool. What do you mean by container orchestration tool? Container orchestration means orchestration nothing but how do you manage the containers. See, for example, if we take the Flipkart application, there are thousands of microservices are running in the Flipkart. There are thousands of microservices are running inside the container. Inside the container. Now, how do you manage all the containers? There is a person to require to monitor applications and to require to manage your containers. So, yes, we can able to use Pato. If you just go to your hub.com, for example, if you required MySQL, now hit the enter. I can see that I can able to create MySQL servers. I can able to MariaDB. We can able to use whatever you want. Okay. Database service also it's possible to deploy into the containers. Okay, fine. Now let's get back to your Docker. Sorry, Kubernetes. So containers are not self-sufficient. So because of this reason only we'll go for the Kubernetes. So Kubernetes is a container orchestration tool and which helps us to how to manage the containers. Okay. Now, when you want to deploy the application to the container, we need to create a cluster. Inside the clusters, we have the master node and we have a worker nodes. It will take 2 hours time to explain the architecture of the Kubernetes, but try to understand about what is meant by master node, what do you mean by worker nodes. Master node is also we can call it as a control plane. Worker nodes also we can call it as data planes. The master node is nothing but now it is going to manage your applications. It is going to manage your cluster. Now, what do you mean by worker nodes? Worker node, when I say node is nothing but a server. Worker node is nothing but where exactly you're trying to deploy the application to the worker nodes. This Kubernetes, it is going to help you to auto scale the applications and also it will help with the load balance applications. Okay. So these are the features will provide by the Kubernetes. We know about what is my auto scale. Auto scale is nothing but when the traffic is increasing towards your orders module or any module, we can able to increase the number of server capacity. That is what we can call as auto scale. Now, what is my load balancer? If your application deploy into the n number of servers, so we have to distribute the traffic between your servers. That is who will taking care of distribution traffic will take the load balancer. Okay. Now, if you want to deploy the application, what you require, we need a cluster, right? I have already ready cluster with me. Now let me log into my cluster. So don't worry about guys. Let's log into my Google. Let's say Google Cloud sign in. Now hit the enter. Go with the Google Cloud GCP platform. Now click on the sign in. Okay. If you just see that there's option called click on the sign in. I have already account in the Google Cloud. It is a free of cost, guys. You can able to create. They will just provide they'll provide $300 as a free of cost. Okay. That we can able to use for practice purpose. They're not going to get any single rupee also from your pocket. Now click on the next here. I'm just trying to log into my GCP console. Let me log into my GCP console. And if you just go to the console, whenever you're going to create a cluster in the AWS or Azure or cloud, it is something what we can call it as a managed Kubernetes cluster. So the cloud people will manage your cluster. We don't require to worry about your cluster. If we go to navigation menu, if we'll just come down, we can see there is a Kubernetes engine, right? If we'll go to Kubernetes engine, click on the cluster. I have already clustered it in my Kubernetes engine. My cluster name is a production cluster. In the cluster, I have 3 servers and I have used 46 CVs, and each server has a 4 GB RAM capacity. If you want to connect your cluster, click on the checkbox, and if you go to actions, now click on the connect. You can see this, you have to click on the run the cloud shell. So we have to understand about how to work with command line interface. So I'm just trying to work in the command interface. Now just hit the enter. When I hit the enter, we can see that it is going to authorize the cloud shell. Click on the authorize. When you click on the authorize, it's trying to authorize your credentials. If you just open the new window, in the worker nodes, we have the container runtime interface called as a Docker. So here, we'll just type the command called Docker --- version. We can see that we have the version called 20.3.50. If we'll observe this diagram, what are the microservices application source code we have written? We build Docker image. This Docker image we can able to store on the Docker Hub. Now, how do you store an image in the Docker Hub? If we'll just go to my hub.docker.com, I can see that the repository, I have all Docker images available inside my hub.docker.com. Now, anyone in the world, they can able to pull this particular Docker images because it's a public images. Now, even I'm just trying to pull this Docker image into the cluster. If you go to tags here, now if you just copy the command docker pull and image name, if we'll go to this particular Kubernetes cluster and just Control V, now hit the enter. What I'm trying to do, I'm trying to pull my Docker image, which we build the Docker image right now. We can see that it is trying to pull the Docker image onto my cluster. A cluster is nothing but is a combination of master node and worker nodes. If you want to deploy the application, we are trying to deploy the application to where? Into the worker nodes. If you want to see the diagram, let me show you the diagram. Let me go to the Docker and Kubernetes and let me go with this Kubernetes image. Okay, go with the Kubernetes image. Then we'll just open this Kubernetes image and we can see that there is a master node, there is a worker node. In the master node, we have the API server, etcd control schedules. It is nothing but how the application should be deployed into the worker nodes. The master node is going to control the application deployments. In the worker nodes, if you just see the components, we have a kubelet, pod, container runtime is nothing but a Docker. Now pod is nothing but is the smallest deployable unit where you are trying to deploy the container inside the pod. Kubernetes doesn't understand the containers. Kubernetes will understand only the pods. Now what is the application which I want to deploy? This application we are deploying to the pod. Now how to deploy the application into the pod? We have to use a command called as a kubectl. Kubectl is a tool. If you want to interact with the Kubernetes cluster, we have to use a command called as a kubectl. So kubectl and use a command called create and a deployment. And if you just type the command called deployment, and you have to mention the command called as a deployment name. See, for example, I'm ready to deploy the application called as a Python, right? So mention Python-demo is nothing but application deployment name. After that, you have to mention Docker image name. What is the Docker image name? hyphen image is equal to, what is the image name? Murli Social 123 testing hyphen py. Just control C. Now, one second, keep curtil, create, deployment, mention Python hyphen demo, mention hyphen image is equal to mention control V. Now hit the enter. See what you're trying to do. So we can see that the application got deployed within fraction of seconds. Now just type the command call keep curtil and get deployments. We'll just hit the enter. We can see that there is application, the Python hyphen demo, and which we deploy inside your inside your cluster. Now, if you want to see this, if you just type the command called kubectl get pods hyphen o wide, we'll just hit the enter. We can see that what is my application which deployed Python hyphen demo. Look at here. We can see my application is running status, deployed 30 seconds ago. Every pod has an IP address. We can able to see which server it is got deployed. I'm not specifying that where it is my deployed application because the master node scheduler will taking care of where we have to deploy the applications. Okay. Now it is got deployed. Right. Now when you delete the application, the Kubernetes will automatically recreate the same application, the same pod. Now for this, we have to type the command called kubectl scale and deployment and provide a deployment name Python hyphen demo and mention your how many replicas you want. If you just mention replicas space 2, now hit the enter. One second, let's provide the command Python hyphen demo hyphen replicas is equal to 2. Now hit the enter. If we'll just type the command called kubectl get deployments. Previously I have deployed only one application deployment. Now hit the enter. You can see that there are two pods are created. Up to date 2. Now available also 1. Now still one pod is got created. Now hit the enter. We can see that it's got updating. Now if you want to see how it is trying to updating, type the command called kubectl get events. Event is nothing but it's going to show you what is the history happening inside the Kubernetes cluster. We can see it's trying to pull the image, testing colon image, successfully pull the image. Inside the pod, it's trying to create a container. Now we can see that started container. Now we can able to see that I want to try to increase my application capacity from 1 to 2 now. We got 2 now. Just type the command called get deployments. Just look at here. 2 applications running successfully now. See previously available 1. Now we can see available 2 now. Now what I will do, just type the command called kubectl get pods. Now hit the enter. Now we can see the pod got created. Now I'm trying to delete the pod. See the Kubernetes, how it is helped to manage your application, because Kubernetes help us to get zero downtime application. If we'll just type the command called kubectl delete pod, mention the pod name. Okay. Now hit the enter. Just try to observe what is the pod which I deleted. 9G, 1G8 is the pod which I have deleted. Now the Kubernetes will automatically create a new pod. This is what we can call as a self-healing feature. The Kubernetes is having a great feature called as a self-healing. If you're sleeping at midnight, if you're sleeping at morning, early morning, if anything happen inside my cluster, the Kubernetes will taking care of each and everything. That is the reason only many of the organizations nowadays are going for the Kubernetes. Each and every organization, they go for the Kubernetes because of the auto scaling, load balancing, and self-healing features. Now just type the command called kubectl get pods -o y. If you just think technically, how many pods should be available right now? Only one pod, right? Now, but if we just try to understand, there are two pods available right now. How it is happening? We can see the new pod created. Now, how it is created new pod? See, this pod got deleted with ID called 9G1G8. The new pod created like the 8GZ61. Now, how it is got created? The Kubernetes will taking care of all these things. That is the beauty of the Kubernetes. Okay, understood now? What is a Kubernetes? Where we go for the Kubernetes, how to deploy the application in the cluster. See, if you want to learn in detail, it will take time. But whatever I showed, it is just demonstration, nothing but how to deploy the application in the Kubernetes platform, how to scale up your application, how the Kubernetes helping us to provide the self-healing feature. So the same way I'm trying to take up the real-time oriented classes, guys. And if you join the demo master DevOps master program, and we will help you out to shine your career. And also I'll teach you from the basic to advanced level all the tools. If anyone interested, please try to contact my admin team, and also they'll help you out with the course details. Also, they'll help you with the fees details also. Okay. It is all about our today demonstrations. Now, anyone have any questions regarding this Docker and Kubernetes? Okay. I hope no questions. Yes. You guys can use the same WhatsApp. Add into Kalyan IT Hub. That's fine. There is a question from Hassan. Yes, Hassan.
Hi, how you doing, Mr.
I'm
Murli?
doing great. How are you?
Yeah, I'm great. I'm great. So the question I have about the Kubernetes. So the curriculum is for 2.5 months, right?
Yes.
This is a basic question about the full course. So if it is start this month, I mean, like from tomorrow or day after tomorrow, 2.5 months. So what is the first thing you're gonna start teaching, and how is gonna be jump? What is the like a process you will go? I mean, I was trying to cop up with you, but somewhere I couldn't get with the Linux. That's the reason I couldn't follow you exactly. I got lost. I will ask the video so that I can understand better. So my question is like, what do you gonna start with Linux, or do you gonna start with Docker or Kubernetes? How are you gonna go step by step?
Yes, great question. So before you understand about DevOps, so we have to understand about cloud platform. What is cloud? What is the cloud computing? Why we go for the different kind of services? So I'm going to start with the cloud computing first. Once you're done with the cloud computing, we have to understand where we are trying to deploy the application first of all, and how these services helping us to deploy the applications. After that, we'll go with the Linux. Once you complete Linux, then we go for the DevOps tools. Okay. This is the flow which I'm gonna take.
Okay, that makes sense. So
Yes.
yeah, so Git and everything would become on a DevOps, but before that,
Tools.
you're gonna be concept with the cloud computing, like, and you are processing most of the AWS or any specific
Yeah.
like, or
We are just using AWS, and we are using GCP for the Kubernetes.
okay, but most of the thing would be in AWS, right?
Yes. Yes. Obviously.
Okay, okay, that was the question. Thank you so much.
Yeah. Does anyone have any questions? I hope you guys are clear. And if you have any kind of question, just try to contact admin team. They'll help you out. Yes. Yeah. There is no questions as of now, I hope. And say that again, sir. I missed the answer. You can able to, once you complete this course, once we complete this course, you can go with this 4+ years of experience knowledge, you will get it. 4 and to 5+ years of experience knowledge, you'll get it. Okay. Yes. Yeah. Thank guys. Thank you very much. Thank you and have a great day. And I hope you see you all in tomorrow's session. Yeah. Thank you guys. Thank you very much.